to screen sharing. Hopefully it'll pick it right up and away we'll go. Is that coming through yet?
Yes, beautifully.
Oh, great. Is it? All right. Well, I have enjoyed all forms of radio communications ever since I was a little kid, and the highlight of my childhood was getting a Star Roamer receiver. It covered 200 kilohertz up through about 30 megs, and it was a cheapy receiver, but I thought it was the most wonderful little thing in the world. I had a great time tuning every single frequency from one end of the band to the other. Uh, listen to the BBC and Radio Netherlands and just all kinds of stuff, and even had Radio Moscow on there one day. And my parents walked in and heard me listening to Radio Moscow, and they just about had a stroke. It'd be like listening to ISIS recruitment radio today or something like that. So I had to avoid that to keep my shortwave radio, but everything worked out all right. I became a licensed amateur radio operator, and then into broadcast engineering and station building and all kinds of things. So there's a section of the spectrum that's largely overlooked, and so I wanted to tell people a little bit about what's going on below the AM broadcast band. So there are a number of segments. Hopefully you see my second slide here. Marine is still occupying a little bit of 480 to 512 kilohertz. Then we've got a ham band, a band I hang out a lot during the winter months on. And then marine and aircraft beacons, European and Asian radio broadcasting. Part 15 on licensed use, which also is known as the loafers. Another ham radio band, the former LORAN navigation, the low frequency version. Then there's the standard time and frequency bands and the military. So we're going to run through what's on all those band segments. So what kind of equipment do you need to tune below the broadcast band? A lot of you probably already have general coverage receivers in your ham rigs. That'll go down to at least 100 kilohertz, and some of them will go down to 30 or 50. So that's one option. You could also look for a used very low frequency converter on the internet or at ham fests. SDR Play makes a very high quality receiver that goes all the way down to 1 kilohertz, and its major benefit is it has a very effective 500 kilohertz low pass filter. That's another option. That's a receiver only, and it's a little pricey, but I've got one of those and I recommend it. You can also get a mini kit 630 meter transverter for $119.95 from Australia, plus some international shipping. The downside to this is it's a fairly narrow band. The good thing about it is it's fairly narrow band, and you're not likely to get a lot of interference with it because it's got a lot of filtering. It uses 80 meter ham band as the IF frequency for both transmit and receive. Then you need an antenna for the low bands, and this is probably why most people maybe checked it out quick and didn't hear anything, and they don't ever use it. One possibility for an effective antenna is using your HF dipole. And the trick is when you bring the coax cable in the house, you short the center and the shield together and plug that into your low frequency receiver. You can also use any non-grounded vertical, either with or without a loading coil. And you can make some tuned loops such as this one. Very effective for nulling noise, and also it's quite useful for AM radio DXing. And then I'm going to show you a picture of my antenna. And there it is. That's what my low band antenna looks like. And if you can't see it, I'll circle it in white. It's just a wire laying on the ground, sometimes called a beverage on ground, although it's not near long enough to be a typical beverage. Some people also call them snake antennas. And when I went outside today to take this picture, there was a snake next to it. So he scurried away before I got the camera out, unfortunately. Otherwise, I'd have included him. So the next thing, well, what's propagation like? What do you get in the daytime? What do you get in the nighttime? Summer, winter, what are all the variables? And the most outstanding thing about low bands is the just outstanding ground wave coverage. In broadcasting, there was kind of a rule of thumb that a 50,000 watt station at 1600 had the same coverage as only a 1,000 watt station down at 540. And that's pretty much true when you take into account the square miles worth of coverage. Also, the lower frequency signals kind of roll across the ground because the interaction with the ground material. Some people call it sticky waves. I'm not sure that's an accepted engineering term, but it's probably fairly accurate. Also, it does penetrate into the ground a fair amount. There are some mine rescue radio systems that operate at very low frequencies. And of course, submarine communications. Below 30 kilohertz, signals penetrate the salt water for hundreds of feet. They don't go to the bottom of the sea, but it at least allows the submarine to stay out of sight and still receive. As far as I know, there's not an effective transmit antenna. So it's a receive-only situation because an effective transmitter antenna would be far larger than the submarine in the form of miles long for transmitting, but receiving, no trouble. Also, beyond the ground wave, very low frequency and medium frequency propagation is controlled by the lower regions of the ionosphere, mostly the D and E layers. And sometimes on the higher frequencies, the F layer also comes into play. Although the D and E layers kind of form a waveguide between the surface of the Earth and the lower ionospheric levels. So it somewhat keeps things trapped. And of course, the downside is high levels of lightning static during the summer. And in my case, I get a lot of noise from switching power supplies from the neighbor houses. This chart shows the permittivity of average soil. Now, permittivity is kind of the opposite of resistivity. So you see the left hand is low frequency side and the right hand of the chart is a high frequency side. And you see how very, very good the soil is for low frequency radio signals. You look at 10 megs, then you move over to 1 meg, and then you move down to 100 kilohertz, and you gained an awful lot of free coverage just because the losses are low. Again, this goes back to that AM radio broadcast where 1600 doesn't propagate all that well by ground wave, but 540 sure does. So let's see. The first stop is marine radio. And the marine band used to be very large, and basically all the marine communications has gone to satellite, and there's automatic tracking systems and satellite phones and things of that sort. So the marine telegraph network has been dismantled. And aside from a few museum stations, there's nobody left on 480 to 520, and that's a splinter of what it used to be. But there are a few signals still there. I checked it out. There's NavTech signals, and this is what they look like at my house. And those are the only 4 marine band signals I could find. And I didn't set up NavTech decoding software, but somebody that had an interest in that probably could do so. So that's really all I've got to report on the marine segment. Next comes an amateur radio band. Yay. 630 meters. Was finally open to the United States hams 3 years ago today, October 13th, 2017. There were some experimenters going earlier than that on various frequencies between about 450 and 500 kilohertz. And they did a lot of the initial research and found out that's a pretty good band. The band is divided up into 3 segments: CW, digital, and wideband, which is basically lower sideband SSB. And the digital modes, this is what you might see if you're just, working run-of-the-mill, who's out there tonight kind of stuff. This was there a date on there? Should be, yeah, October 13th. So that would have been last night and this morning. So there's activity there, and it's easily decoded with Wsjt. Let's see, and you can actually do a little better than this. This is probably, maybe stations within about 1,000 miles of here. Then you can go a bit further in this, and here's N9LB in Malachi, Hawaii. He's at grid square BL11 Juliet Echo. And that's 6,654 kilometers away. And this was the guy that was coming in, I think it was 58 times between his sunset and my sunrise. So some decent DX is available. I've also copied WL7L in Alaska and several stations in Australia and most of Western Europe on this band. I have heard Western Europe this fall, but not reliably and not every day, but that's coming. I think we'll have it as soon as the thunderstorms clear out. So that takes us down to marine and aircraft beacons, 190 to 430 kilohertz. And this is a list of the long wave beacons at Wisconsin airports. I wasn't able to receive all these. I tuned around and listened for them, and a lot of them I could receive, and more than half I could not receive. I don't know if they've shut them down or not. Most of the beaconing is now on VHF, the Vortac beaconing system. And but a lot of these are still on, and here's some that I located. You can tell these are modulated CW. In other words, they're AM transmitters with 1,000 cycle audio tones fed in, identifying them in CW. You should be able to see the keying there on the various carriers. There's also a lot of switching power supply noise mixed in there, which does make reception kind of difficult. I'll go back to the last slide. The first column is the frequency, and the second column is their call signs. Notice there's all kinds of wacky call signs. There's seems to be no rhyme or reason to them. UNU on 344 comes in very strong at my house, and that's Juneau at the Dodge County Airport. Some of the other ones are SLY and Hayward at 344. Probably don't get both of those because they're on the same frequency. These are only meant to cover maybe 100 miles out from the airport or so. They're not meant to be long range, and they're very low power. There are people that collect beacon reception reports. I don't plan to do that. I like to go after the two-way stuff for the most part, but it is out there, and it's something you can try receiving. You can Google your state for frequencies. Let's see, and let's see, we already looked at the signals. So Europe and Asian broadcasting, and this is kind of sad here because about 90 or 95% of the broadcast stuff is no longer running on the low frequencies. These are the only stations I could find on the internet that claim they were still on the air. And in the past, the listening guides had many hundreds of stations, and this is what, about 15 or so. They're running big power though. As you can see, 50 kilowatts is about the lowest, and 2 megawatts is about the highest power levels. And huge antennas, by the way. To get some decent efficiency, you need just gigantic antenna systems. This happens to be a low frequency broadcaster in Motala, Sweden, if I pronounce that right. This is Belgium Longwave Broadcast Center. I know it says TV transmission, but it's clearly mislabeled. This is the station BOD 153 kilohertz in Romania. Just a drawing of it. The antenna is actually the blue traces you see here. The two towers are simply support structures. They don't have anything to do with generating the radio signal. It's one form of a flat top, or some people would also call it a Marconi antenna. So that takes us down to the loafers, the unlicensed people. I think that there's very little activity here, but I did find a current list of who's on the air. And this is dated the 19th of September. And you can see in the frequencies on the left-hand column and the made-up call signs they're using. A number of these people are hams, but they using your ham call on an unlicensed frequency really isn't a good thing to do. So they have alternate credentials that they create. A problem with the non-licensed stuff is you're only allowed 50 feet of antenna, and that includes your transmission line. And you're only allowed 1 watt, which that's transmitter power output, not ERP. There's a huge difference. 1 watt of transmitter power is probably a microwatt or 2 or 3 with an antenna that small. If there's somebody in your town, you know, the Illinois ones we might be able to hear in Wisconsin, but these are definitely not doing any transcontinental communicating. Let's see, we'll go down to the next ham band. Yay! 135 kilohertz. And hey, a fun fact here. Notice it says 1 watt effective isotopic radiated power. Well, the big secret there is amateur radio operators are allowed 1,500 watts of transmitter power into an antenna that's less than 200 feet tall. And so if you have like 190-foot tower and you put 1.5 kilowatts into it, you might be getting 1 watt of effective radiated power, simply because it'd be like using a 4-inch antenna on 20 meters, you know, with a big loading coil at the bottom. It's just very, very inefficient. The loading coil will make lots of heat. There'll also be some pretty severe ground losses, even if you have ground radials there. But running high power is the secret. Here's a screenshot of Wsjt. The new version, by the way, 2.3.0. This was a developer version. And here you have a station in Australia talking to a guy in Oregon, Wisconsin, or Oregon State. And signal levels -34, -17, -22. It's communications, digital communications, but it is working. So you can do some pretty amazing things on 136 kilohertz. I am active on that band as well, but there's very few people there, and everything's digital there. I've never seen CW, and SSB is not allowed because the band is narrower than one SSB sideband. So it's only narrowband digital. So moving along, time and frequency standard stations. And there's a fair number of these around, and they put out a heck of a signal. You may be familiar with the ones that are sister stations to WWV in Boulder, Colorado. Of course, mentioned WWV. There's also time signal stations and frequency standards in Germany, Japan, Russia, China, and France. And these are all active right now. You can easily tune in to at least WWVB. And here's what it looks like at my house. It's just a rock solid 60 kilohertz, 40 dB above the noise signal. You can pick this up on wristwatches. You can pick it up on the radio clocks hanging on your wall. It covers all of North America, no sweat. This is what one of the clocks that you might find in the store or on the internet. It says radio controlled, or sometimes they say atomic clocks, but they're actually running on the 60 kilohertz signal coming out of WWVB. This is the one in my shack. Notice the signal's being received, it's okay, and it says it's an atomic clock, and it's accurate to within a second. And it works summer, winter, daytime, nighttime, thunderstorms or no. It's a real nifty little shack edition, and I think it was $29. Casio also makes a wristwatch. I've never seen one of these, but they're listed on the internet, and this works internationally on any of the standard time and frequency stations. I've never seen one work. I don't know how well they perform, but apparently they are available. This is a standard frequency receiver that receives WWVB at 60 kilohertz. When I was transmitter engineer at Channel 3 in Madison, Wisconsin, I maintain one of these systems. All the TV stations on Channel 3 were plaguing each other with beat notes between their carriers. And so they all got together and said, boy, we can't afford a CCM frequency standards, but we can afford these receivers. And so all the Channel 3 and also all other low band TV stations put these in and lock their carriers together. And the chart recorder tells you how many degrees out of phase you are with the reference, because you have your local oscillator, and then you have WWVB coming in on that loop antenna in the white plastic tube. And we had that exact antenna sitting on the roof of the transmitter building, as a matter of fact. And the chart recorder showed you how many degrees out of phase you were during the day. And day and night, it would be rock solid, but sunrise and sundown, you'd have skywave and ground wave interfering with each other. So you just let it interfere and you watched on the trace. And you know, you didn't dare adjust it unless your all night and all day had a phase error. And that allowed the TV stations to stay well under 1 hertz difference in frequency from the others. There are also some AM radio stations doing that, and I think a number of TV stations from channel 2 to channel 6 use that technique to extend their coverage areas by reducing the co-channel interference by locking the carriers together. And the signal coming from Colorado, let's see, originally they had 2 of them, WWVB, which was on 60 kilohertz, and then they experimentally had WWVL at 20 kilohertz. And the idea was the 20 kilohertz signal was going to be the heartbeat for the world. You know, the whole, everything on Earth would be referenced to WWVL. And they built the station. They didn't have a lot of money for a transmitter, so it was fairly low power. But the National Bureau of Standards and Harvard University in Massachusetts each set up a cesium standard frequency device, and then they monitored the phase errors between Colorado and Massachusetts, found it was basically no errors at all. That low of frequency at 20 kilohertz was just there. Unfortunately, it didn't provide worldwide coverage because they couldn't afford the multi-megawatt transmitter. So WWVL only lasted about 10 years as an experiment, and they shut it down. And now WWVB uses it as an alternate antenna. And sometimes they even connect the 2 together, running on the same frequency, and get about 20% more effective radiated power by having twin antennas instead of just one. This is a look at the WWVB antenna. Up on top of one of the towers, you can see the wire mesh fanning out. It's like a giant fishing net made out of a special type of bronze wire that is very conductive and very resistant to corrosion. These are the support towers. And this is when the antenna is lowered down for maintenance, and you can see just how it's composed. And by the way, I've got a little version of this in my backyard. It only measures 44 by 55 feet, but it's the same kind of antenna. And that takes us way down to military frequencies. And this is where there's some surprisingly huge plants that are still in operation. They, unlike the other military low frequency stuff that's all been dismantled in the last 20 years or so, the 10 to 30 kilohertz stuff is still there. This is a list of some of the VLF transmitters that are currently operating. As you can see, there's quite a few of them around the world, and the United States has the most. And we also happen to have what are believed to be the most powerful. And we're going to look at one of those here in a minute. The type of antenna generally used when you're basically down at the audio range is called a flat top or a triadic antenna. And this is a schematic diagram of one they came up with over 100 years ago. And it's basically still the same starting point. It's kind of half a Marconi would be one way to look at it. But it's a lot of wire suspended as high up in the air as you can get it. And how do you watch signals down at 20 kilohertz. Well, as it turns out, there is software that you can put on your computer that turns your sound card into a spectrum analyzer. Originally, this was done by audio engineers for like checking noise in an auditorium, and they'd take a white noise generator and stick it in their auditorium, and then a microphone, and they'd check the acoustics of the auditorium, you know, see where the peaks and the dips were, and they could actually tune auditoriums and recording studios for a cleaner sound using this technique. Well, this turned out to be a very popular thing, and somebody came up with the bright idea, instead of plugging a microphone into it, why don't we plug an antenna into it and see what we can see? And sure enough, it works. In this one, you can see 4 of the very low frequency stations between about 19.5 and 21.7 kilohertz coming through just fine. Here's another piece of software that does basically the same thing. This one has a sound card that will go up a bit higher in frequency. I think it goes up to 96K. And not only can you see the you know, 16, 18, 20 kilohertz stations, you can also see some of the higher frequency ones up in the 30 and 40 kilohertz range. And here's yet another one showing various signals coming in. And some of the software even has decoders in it that can decode the modulation on these carriers. It's slow speed, usually frequency shift keying. And this is one of the examples of what you get out. This was a station transmitting, looks like 18.1 kilohertz with plus and minus half a kilohertz keying. And this is what the submarines are listening to and whatever else is being communicated with. I have no idea how to decode it, and it's probably a big government secret, so we're not even going to try. This is the Cutler, Maine U.S. Navy submarine transmitting station. There's actually 2 antennas here, the front antenna and the back antenna, main and backup. Although just like WWVB, they can hook them together for a little better efficiency. And you can't see the wires here, but a schematic is right there. And you can see each of the feed points has 6 of the flat top antennas all connected together. And it's supported by a number of towers. They're about 1,000 feet tall, each tower. And this is their antenna tuning unit for one of the antennas. And I just want to show you the man sitting there looking at the camera. I don't think this is turned in, or he'd be instantly French fried, but apparently he's one of the engineers that put it together. Here is the construction crew hooking up the interconnecting wires. This thing that looks like a Z, that's one of the range selecting switches. And this system, as originally designed, would cover, I think it was something like 15 to 25 kilohertz, although they probably leave it at one particular frequency. And you can see the windings of the coil in the background there behind the switch. I didn't find a picture of the control room that was quality. This one looks like something was stolen out of a newspaper or something. But if you Google the Cutler, Maine VLF transmitter site, they have a number of pictures of what they've got there. Then, last but not least, there is an Anderson alternator still in a running condition in Sweden. And what you're looking at is on the right side is a big electric motor. And on the far left side is a AC generator. And in the middle is a very complicated gearbox that basically when they start up the motor, they start out in low gear and get the AC alternator at the other end turning pretty fast. Then they shift gears and they go a little faster, and they shift gears and they go a little faster. And eventually it turns so fast they're making radio signals instead of electricity. This is from the most recent day they were operating. They operate a couple times a year on, I think it's 17.4 kilohertz. I'll have to check into that. But this is the alternator, just like the alternator in your car or the the AC generators at the power plants, except it's got a lot of pole pieces and it turns just crazy fast. Maximum speed on these is just enough that it doesn't blow apart through centrifugal force. And let's see. Again, this is the flat top or triadic antenna plan. And what the people in Sweden did is instead of putting up 2 towers for each of the supports, they just put up 1 tower and ran antenna wires on each side. And they figured they needed only half as many towers to do that. And these towers were put up in 1918. And the reason they did that is during World War I, the Germans kept cutting their telegraph lines. And they said, we can't be out of contact with the rest of the world. So they built up this long wave transmitting station. And it was in use through, I believe, into the 1950s. Oh, one thing I forgot to mention. Let's go back to the Anderson alternator. We'll use that picture. The United States Navy had 7 of these, and they used them through World War II and only took them out of service in 1948. So they're remarkable machines. They generate a crazy amount of power and relatively stable frequency. It's not like arc gap or sparks or anything where you put out wideband garbage. This was a real nice clean sine wave. And basically they used them to communicate with the Atlantic and Pacific fleets during World War II. And it was a preferred method for CW communications because they didn't have to worry about, what the solar numbers were or, day or night or anything else. When they'd fire these up, it was right there. There's old technology, but it was very proven technology. And I was surprised to hear that. And one of those Anderson alternators was donated to the Smithsonian. They have it, but I don't believe it's on display. And the other 6 were scrapped. So we've got one in mothballs, and this one is still operating. I think Christmas Eve is the next time they go on the air. And I tried to receive them. I think it was, I forget the date. Maybe it's on the 5/22, it looks like. Or maybe it was 5/27. Anyway, I wasn't able to pick them up. I picked up every switching power supply in the neighborhood, but I did not pick them up. But a number of hams on the East Coast were able to receive them without much difficulty. I believe they were all running battery operated receivers, and they went out to wetlands or seashore to make their receptions. And of course, they sent in a QSL card and they got one back. So that's it. That's what's going on below the AM broadcast band. And I hope you enjoyed it. I wonder if there's any questions.
Excellent, Lloyd. Very nice.
I'm glad you enjoyed it.
Very much.
So
Do you know what power they were using with their Alexander?
I think right now it's on the internet. They've got a really nice website. It's a living history museum. It's a very noisy machine. When you look at the videos that they use, that they make, you'll notice everybody's wearing hearing protection in the room. And the Swedes still use that as one of their broadcast sites as well. So it's not just a museum, it's a working museum. I believe they have AM, FM, and television broadcasts coming out of there at that same site. And that probably helps keep the museum alive because it's a working site. They have heat and staff and reliable power, so it's a perfect museum opportunity. But I know I think it's somewhere 100 kilowatts or maybe a bit more, but I'm not sure. And they might be running it easy just because they don't want to burn the poor thing out.
Right.
Lloyd, I'm looking at my WSGTX software version 2.2.2. Mode FST4 was on your slide. I don't see it on my menu.
You have to scroll down the page a little more and get to the 2.3.0 release candidate 1.
Okay, 2.3.0. And would you go upper sideband with that if you're listening 472?
Yes.
Okay, thank you very much, Lloyd.
Yeah, it's upper sideband for the digital modes in both 136 and 472. Lower sideband if you want to do voice.
Got it. Okay, thank you.
But most of the people on voice on that band seem to be in California. I don't know why the rest of the country isn't doing voice more, but a lot of people like the easy documentation of propagation. And, it's just like running FT8. That's something else they changed. Now auto sequencing is available, which was not available with JT9. A lot of people are happy about that.
Yeah, I noticed that on JT65 as well.
Cool.
Lloyd, that was a really outstanding presentation. Thanks very much. We usually think about best conditions for the low bands at the low part of the sunspot cycle and the worst times for it at the top. But how does that apply to the very low frequencies that you're talking about? You have any idea?
Well, I've only been on since last year, but from what I've been able to gather from the people that are around for the last 10 years with the experimental licenses, is that the band just works. It's good sunspots or not. Let's see, some of the solar events do kind of mess up the ionosphere a little bit. The X-ray things coming in from the outer space and some of the stuff the sun throws at us do affect it, but it doesn't knock out the ground wave at all, of course, and skywave is variable.
Yeah, thanks for that. Well, that's interesting. We had N9LB on here previously. I wish that Carl was around to comment on this, but it seems like he's not with us anymore here. Yeah, looks like he signed off.
Okay.
Okay.
Question.
Go ahead.
Lloyd, have you ever listened below 10 kilohertz to whistlers?
No. Tell me about it.
Well, I wish I could. I was hoping you would. That's lightning that you listen to, and I guess it's quite entertaining. So
wow.
I'll try that sometime.
Yeah, maybe I will too. Thank you.
There's some internet stuff for the recordings of whistlers, and there's another effect called the morning chorus, which sounds like frogs or something. And if you do some searches, you can hear recordings of it. And I have a question, Lloyd. The new mode, the FST4, there's a bunch of different times involved? Is there a standard one everyone's using on
Most
630?
Yeah, most everybody is running either the 60 or the 120. I know some of the people have played around with the 15-second. What do they call that? It's I'll have it here. The FST4/4 would be 15 seconds. /2 would be 30 seconds. So kind of doing the same thing that FT4 did for FT8. They're doing with the, above and below the standard transmission and reception time periods. But 60 seconds and 120 seconds are what I've seen being used actively.
Lloyd, on the 630 meter band there, are there guys operating CW there?
Yes. Yes, there are a number of CW stations, and I had a screenshot of them and I lost it. I was going to include that in my presentation, and it looks like it got overwritten or something.
Have you listened to the CW guys on 630?
Yeah, just for the heck of it, I made a couple of contacts.
What kind of distance?
I think East Coast, which is no big deal on that band. That's easy to do.
That's nice.
Yeah, I worked the state of Oregon, what was it, 2 nights ago or 3 nights ago, N9LB. So I've got 31 states now. I'll see how many more I can add this year.
Boy, congratulations.
Yeah, there's 1, 2, 3, 4, 5, 6, 7 states that have no operators on either band.
Well, it's
So,
a paradise.
well, they're going to start doing portable operations.
Yeah.
There are some legal challenges because to use those bands, you're supposed to clear it with the utility coordination, UTC, whatever that is. And so presumably these portable stations would have to get clearance for their portable locations.
It was kind of a joke because if you're going to operate portable, you got to have some place to string out a bunch of wire.
Yeah, a potato gun and a big roll of wire and a tall tree are really good. And, if you're in town, you hook your ground connection up to the local fire hydrant, and that low a frequency, it doesn't matter that it's down 6 or 10 feet because the ground penetration's unreal at that frequency. Or you could lay out radials on the ground.
Just bury a bunch of old cars.
That would work.
Hey, can I ask something here? We have 2 folks on here. One is James and one is Bart. Can you tell us what your calls are, James?